The topic for this video is scale drawings. A scale drawing is an enlarged or reduced drawing of an object. A scale is a ratio that compares the measurements to the actual measurements of the real object. Here I have a picture of a scale drawing. So all a scale drawing is doing is it's showing you, rather than you can't look at the actual campsite or looking at the campground, you'd have to be up in the sky to do that. So a map is a scale drawing showing you the campsite. And then if you notice right below it, where it says 2 centimeters equals 100 meters, this is the scale. It's telling you that for every 2 centimeters on the map, it equals 100 meters at the actual campground. Our example says that Camp Namekagon, this is the map, that's the map of Camp Namekagon. The shower house to your campsite is 3 centimeters on the map. How far is the actual distance? In order to solve with scale drawings, you have to make a proportion. And when you do a proportion, we're always, for scale drawings, going to do map over actual. So we're always going to do map over actual. And we're going to set up a proportion. Our first ratio is going to be our scale. And remember that our scale is this 2 centimeters equals 100 meters. So our map tells us that every 2 centimeters is 100 meters actually. And we're going to make a proportion, so we're going to make another ratio and set it equal to. Now we take a look at our problem. It says the shower house to your campsite is 3 centimeters on the map. And we need to find the actual distance. So that tells us that we have the map's distance. So we have 3 centimeters, the map distance, and we're looking for the actual. To solve a proportion, remember that we do our cross products. So what we're going to do is we are going to multiply the numbers that are diagonal from each other and divide it by whatever number is left over. So we are going to multiply 3 times 100, which is 300, and then we're going to divide it by 2 because that's the number that's left. And 300 divided by 2 is 150, and it's meters because we're talking about the actual. So our answer is 150 meters. Here we have another scale drawing. This scale drawing is of a train, and it tells us that our scale for this drawing is at 3/16 of an inch equals 1 foot. Our example says the height of the train is 3 inches on the map. How tall is the actual height of the train? So what we need to do is we need, again, map, we need to do map to actual. And we're going to use our scale first. Now, we don't want to put a fraction as our numerator, so we're going to change this fraction to a decimal. And remember, to do that, you take 3 and divide it by 16. 3 divided by 16 is 0.1875 inches. And that's, and our denominator is 1 foot. And we need to set it equal to another proportion. When we take a look at our problem, it says that the train is 3 inches on the map, and we need to find the actual height. So 3 inches is going to be our numerator, and we're looking for our denominator. Again, we use cross products. 1 times 3 is 3, divided by 0.1875. If you do that in your calculator, 3 divided by 0.1875, you get 16, and because we're looking for the actual height, it's feet. So our answer is 16 feet. The next thing that we need to talk about is a scale factor. A scale factor is a scale written as a ratio without units in simplest form. So it's writing it as a ratio, but instead of having inches and feet, you're changing it to 1. You're not going to have 2 different units. You have 1 unit. Our example says that a scale for a map states that 2 inches equals 4 feet. What is the scale factor? Again, we always start with map to actual. We always put scale drawings as map over the actual. Our map is 2 inches, and our actual is 4 feet. Now we want to get rid of these units, and the only way to get rid of these units is to make them 1 unit. So instead of having 2 different inches and feet, you need to have 1. So in order to do this, we need to change our feet to inches. Well, if you think back to previous years, you learned that there's 12 inches in 1 foot. So if you have 4 feet, you're going to multiply it by 12. So we have still 2 inches as our numerator, and 4 times 12 equals 48. So we have 2 over 48. But this can be simplified. Both our numerator and our denominator can be divided by 2. 2 divided by 2 is 1, and 48 divided by 2 is 24. Therefore, 1 over 24 is the answer. Very often you guys ask me the question, when will I ever use this? When will you use scale drawings? Well, one example is if you're putting together a model airplane, or if you're in the Air Force, or army or anything, you could be using pictures like this, a scale drawing of the actual airplane that you either are going to fly or ride in or help put together. Here's another example. This is a map of Florida, and you can see all the other islands around us. You've got the Bahamas and everything. Well, most of you are saying, we got GPSs now. Well, yes, we do have GPSs. But when we have a hurricane coming at us, which we had one this year that took out 2 days of school for us, when we have hurricanes, they will actually use maps like this with a scale showing you how far away it is, and you should be able to read it. Or let's say you just bought a new desk and you need to put a new desk together. They're going to give you a scale drawing. Otherwise, if they didn't make it to scale, if they didn't make it look accurate, an actual scale drawing, you might not know which piece goes where. Those of you who want to be an architect or planning on designing your own home or building your own home, you need to have a scale drawing of your house. That's what a blueprint is. Or let's say you work in a big corporate office and you guys are planning on building a new hotel. Often, in order to get people to give you money, you have to have a scale drawing of what it will look like, what the finished product will look like, as in this picture here. This concludes the notes for scale drawings.